Welcome, this is Mr. Hawkins, and today we're talking about slope-intercept form part 1. So, if you read the if you read this, it says Xander has biked 2 miles so far this week and planned to bike an average of 6 miles each day over the next several days. Xander wrote an equation and created a graph to represent x, the number of days, and y, the number of total miles traveled on his bike. Find the slope of the graph, where do you see it in the equation, and find the axis on the graph, where do you see it in the equation? So let's focus on the first one, slope. So if you take 2 points from this graph and you look at the height between those 2 points, you can see the first point starts at 2 and the last point starts at 8. And so you can see the difference in height between 2 and 8 is 6. If you look at the run or the length of that, you can see the length between the 2 points is 1. So our slope is going to be 6 over 1 because of this. We draw a line straight down. It's kind of hard to see because it kind of blends into the graph, but it's there. Draw a line straight over, and our graph is 6 height. What? Come on. Oh, okay. I don't know why that happened. Hold on. Oh, because I forgot to make the box. That's why. All right. So it is 6 height, and it is 1 length. So you can see my slope is my rise over my run, so it is 6. If you look up here, 6 appears right before the x value. This is where my slope appears in an equation. 2 is where it crosses my y-axis. So you can see here, total miles, it crosses at the 2 point, and 2 appears right here on my equation. So we got those. Let's continue onward, and we'll discuss more about this down here. Slope-intercept form, or y equals blank x plus blank, is one way to write the equation of a blank relationship. So, of course, this equation is mx plus b. So, mx plus b and the type of relationships we're looking at are called linear relationships. My headphones just fell out. I'm going to do a sound check really quick because they're low on battery. And never mind. All right, they're still working. Perfect. So, linear relationship. The y-intercept of the graph is the value of y where the line meets the y-axis. You could also say intersects if you're so inclined. Or you could also say when x equals 0. Pretty easy so far. The m value is the slope, and this is the y. There we go, y-intercept. There we go. In 1 through 3, use the given information to write an equation of the line in slope-intercept form. My mom is like the nicest lady in the universe. She's encouraging me to keep going. I love her so much. All right, so it says slope equals -9 and y-intercept equals 2. So remember, slope is where the m value goes. That's always with our x. So this value is going to be -9, and y-intercept is going to be 2. So there's our equation for that line. Very, very simple. So you can see this one. It tells you the m and b. You just have to write out the full equation. So we're going to write m equals 4. Nope, not 3.5. 4.5x plus -10. Easy as pie. And a line has a slope of -5 and passes through the origin. Now, that's a little bit tricky because you have to realize where the origin is. So if you go up here to the graph and you zoom in, at this point right here, that is the origin at 0, 0. So what is that y value at 0? Well, it's 0 because it's the origin, 0, 0. So in this case, we do not have a b value. Our b value is considered to be 0. So we can say, oh, this is just y equals -5x. And if you want to say plus 0, you can, but you don't need it. It's redundant. And simplifying is always best, getting rid of redundancy. Okay. Let's take a look at some of these. Complete the table in the graph by recording the slope and the y-intercept by making a sketch. So this one, you don't have to be super exact. You just got to give me a ballpark graph. So I'll do the first couple with you, and then I'll let you do some by yourself. So m in this case is, oh well, it looks like I don't have an m. It just says x minus 5. Where is that m value? Well, it's still there. It's just, it's a little hidden. So m in this case would be 1 because 1 times x is still x. So my m is 1. Oop, didn't mean to do that. And my b value for in this case is -5. So for this graph, I'm just going to start in the negative slot position. I'm going to make sure my slope is positive because it's 1. And I'm going to go up 1 over 1. Something like that would look like my slope. Here, I don't have a b value. So my b value is 0. And it's a positive slope, so it's going to go up 3 over 1. So it's going to look a lot straighter than that. It's going to grow faster because it is a steeper slope than 1. So it might look something like this. It's passing through the origin point. Here, I'll let you guys figure out this one. Good luck. All right, in your next page, the practice. Oops, sorry. You can see for each graph, record the slope, y-intercept, and the equation in slope-intercept form. So first, I'm going to identify my y-intercept. So I'm looking at my y-line, which is here, and where it crosses. So that's my y-line, okay? And it looks like it crosses at 3. So I'm like, okay, my b value is 3. Easy. Then I'm going to determine my slope by looking at my rise over my run. So I'm looking at 2 points. So I'm looking at a triangle that goes over and then up. And it looks like it only goes up by 1, but over by 1, 2, 3. So I'm going to say, okay, my slope must be 1 over 3 because my rise is 1 and my run is 3. Love it when things don't work. So my final equation, remember it's y equals mx plus b, but it's y equals 1 over 3 x plus 3. Easy as that. For the next few, I'm going to let you try it out yourself. you do the same thing. And let's see. I'm going to let you try out the rest of this, and if you have any questions, you can ask me in class next time. Thank you for joining. I really appreciate you watching my video, and see you next time.